Hi everyone, Tina here, and today I'd like to talk about 3D Pythagoras and trigonometry. This is a topic you'll only need to worry about if you're doing the higher GCSE course. I think the best way to tackle this topic is to just work through some examples, so let's make a start. Example 1. We've got a diagram showing a cuboid A, B, C, D, E, F, G, H. AB is 5 centimeters, so I'm going to pop that on the diagram. AE is 6 centimeters, and AG is 12 centimeters. AG is actually the diagonal length that goes all the way across the cuboid inside it. The trick to these questions is to visualize two-dimensional right-angled triangles inside the 3D shape. So we can see here that that diagonal is actually the hypotenuse of a right-angled triangle sitting inside that cuboid there. We're told that that length AG is 12 centimeters. The goal for this question is to find the length of AD. So I'm going to label AD with an X as a reminder that this is what we need to find. Now we need to figure out how we're going to find that. And that X is actually sitting on another right-angled triangle, which is hiding on the floor of the cuboid. So if I just highlight that in green, hopefully you can see what I mean. There's another flat right-angled triangle there, and X is one of its lengths. Now, because this is a cuboid, we know that the length DC will be the same as AB, so we can label that as 5 centimeters. So it'd be really helpful if we knew the hypotenuse of the green triangle. There must be a way of working that out, and it's going to be by using that original right-angled triangle that we first drew inside the cuboid, because we know that GC is also 6 centimeters, and therefore we can do Pythagoras on this blue triangle. Let's go ahead and do Pythagoras' theorem. So a squared plus b squared equals c squared, where a can be this length, b can be this one, c has to be the hypotenuse, remember? And then we just plug in our numbers. A is what we want, b is 6, C is 12. If we work this out, we're going to get a squared equal to 108. Therefore, a is root 108, which simplifies to 6 root 3. So let's put 6 root 3 on the diagram here next to a. And now if we focus in on the green triangle that's on the ground of the cuboid, we can do another application of Pythagoras to find x. So I find with these questions, it's all about staying organized. So now we're focusing on the green triangle. We actually have to relabel it if we want to use Pythagoras again, because this time what was A is now C, because it's the hypotenuse. And X can be A or B. Let's call it A. And B is now the 5 centimeters. So focusing in on that green triangle and doing Pythagoras again, a squared plus b squared equals c squared. I'm going to write x this time for a, so x squared plus 5 squared equals 6 root 3 all squared. Working this out in a calculator, for example, gives x squared equals 83, and therefore x equals root 83, which to 3 significant figures works out to be 9.11. In summary, example 1 was just 2 applications of Pythagoras' theorem. Example 2, another problem in 3D, but this time we have a prism. Always read the question carefully and check that all the information is on the diagram before you start to do any sort of calculations. Looking at this, CD is 7, that's on there, AD is 10, and angle FDC is 30. We want to calculate the size of angle AFC. Let's put that on there, AFC. A and F are not currently connected, so let's connect them with a line. AFC looks to be this angle here. Always labeling what we want with an X and then making a right angled triangle within the prism again. Actually going to highlight this triangle in pink. This will be the triangle that contains the missing angle that we want eventually. Before we can do anything with that pink triangle, we need some more information about it. So let's check. Do we know the length of it? No, we don't know the height either. So those are the 2 things that we probably want to find. Let's see how we do that. Again, there's a right angled triangle lurking on the floor of the prism. So if I make that one green, and we've got 2 measurements on that green triangle, 10 and 7. So we can use Pythagoras to find the third side. Let's do that first. So a squared plus b squared equals c squared. Labeling the sides, so a, b, and c. 10 squared plus 7 squared equals c squared. 10 squared plus 7 squared gives 149. So C is root 149. I personally always prefer to work with surds in these kind of questions until the very end, where we can round the answer to whatever they want at the end, because then it's easier to type into a calculator and you know you're not going to lose any accuracy marks as well. So C is root 149. Let's pop that one on. Now we know the length of the pink triangle. It would be really useful to know the height as well. So to do that, let's have a look at what other information we're given and how we could use it. I can see another right angled triangle lurking on the side of this prism, so I'll make that one orange. And in this right angled triangle, they've actually given us the angle 30. Whenever we have an angle involved as well as side lengths, that should be a clue that trigonometry is going to be involved, so SOHCAHTOA. As soon as we think we're going to use SOHCAHTOA, let's label our sides. In this case, not using A, B, C anymore, but using O, A, and H. So H for hypotenuse of the orange one, O for opposite the angle, and then A for adjacent. Different people do SOHCAHTOA differently, but I prefer to use formula triangles. So I will write down SO, Ka, and TOA on the side. Then I like to highlight what I have. So I have A. I also like to highlight what I want. So in this case, I want O. And that then reveals which formula triangle it is that you want to use. So in this case, TOA. We select TOA. We go ahead and do the calculations. If we want O, we cover that up and it tells us that O equals T times A. So O is going to be tan 30 times 7, which works out as 7 root 3 over 3. There we go. Let's pop that on the diagram. Great. So now we should be in a position where we know enough about the pink triangle to work out the angle X. Sometimes with 3D Pythagoras and trig questions, the diagrams can get a little bit messy. So if you're struggling to see what's going on, you can always redraw the right angle triangle somewhere else on the page. And for this particular question, that's what I would do. So I would take the pink triangle and draw it out separately somewhere and just label on exactly again what it is I want and what it is I now have. So I know that this is now 7 root 3 over 3. And I also know that that's root 149. This now just becomes another trigonometry SOHCAHTOA problem. So go ahead and do whatever it is you normally do for trigonometry SOHCAHTOA. In my case, I like to do the formula triangles. So I'll write down SO, Ka, TOA again and do the highlighting trick. I want the angle this time. Got to label the sides. Let's label O, A, H. And I have both O and A. So again, looks like TOA is the one we're going to want to use. This time, because it's the angle we're trying to find, it's actually T that we cover up. So tan X, missing angle, equals O divided by A. And if we pop the numbers in for O and A, that's root 149 over 7 root 3 over 3. And then to get X out, so to release the X from the tan X, you have to press Shift tan in your calculator. Remember, it's inverse tan or inverse sine, inverse cos, whatever the function is, to release the X and get the angle out. So X equals tan to the -1 or inverse tan, shift tan, however you want to say it, root 149 over 7 root 3 over 3. Typing that in carefully into the calculator and 71.7 should come out. Last example. So again, we've got a triangular prism, but this time we're looking at it from a different angle. Just going to check that all the information that's in the question is on the diagram. So AF is 10, AB is 24, BC is 8. Angle FAB equals angle ADC equals angle BDC, and they're all equal to 90. And we want to work out the size of the angle between the line BE and the plane ABCD. Now, a plane, you can think of that as just a flat surface. So in this case, the plane ABCD is the rectangle that's on the base of the prism. The angle between BE and the base of the prism will be easier to see if we draw another triangle within the prism. So something like this, and it's this angle here that they want. Okay, so again, I'm just going to highlight that triangle in pink. And that's going to be there waiting for us to use to find X eventually. But again, there's not really enough information there yet. So we do know that that length is 10 centimeters as well from the measurement in the front of the prism. But it would be good to know the base of that triangle as well. In order to do that, we can use the right angle triangle that's on the floor of the prism again. So I'll just make that green. Once again, looks like a Pythagoras situation. So 24 here, 8 here. So we can go ahead and do A squared plus B squared equals C squared, where A is 24, B is 8, and C is the hypotenuse always. So 24 squared plus 8 squared equals C squared. This means C squared is equal to 640. So C is root 640, which is 8 root 10. So just going to pop that on 8 root 10 there. Now, up to you whether you want to redraw the triangle again, but in this scenario, I would probably just put the O, A, and H straight on the diagram we already have because there doesn't seem to be too much going on. So focusing on the pink triangle, this would be O opposite the angle X. This would be H, hypotenuse, and the 8 root 10, the thing that we just found, would be the adjacent. So again, thinking about SOHCAHTOA, writing down our formula triangles, and then highlighting what we have. So we've got O and A, so I'll just highlight those. So once again, it seems to be TOA. Now, it's not always TOA and tan, but in these examples, it has been. So we select our formula triangle. And again, in this scenario, it's actually the angle we want to find. So it's tan T that we're covering up. Tan X equals opposite over adjacent. So in this case, tan X equals 10 over 8 root 10. And then to release X, to get X, the angle out, remember we said we're going to press Shift tan, inverse tan, 10 over 8 root 10 and 21.6. And that's it. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else that you think might find it helpful. Thanks, and see you next time.